Okay, question 4. You pull a cart with a force of 20 newtons. The handle of the cart makes an angle of 30 degrees with the ground. Express the force vector in terms of the basis vectors I and j. All right, so you see we have our cart here. We're pulling this cart with this force vector F that has a magnitude of 20 newtons. And we're told that this force vector, right, forms an angle of 30 degrees with the ground. So in other words, 30 degrees with the horizontal. And our job is to write this blue force vector F in terms of the basis vectors I and j. All right, so to do that, we can make use of this right triangle, and noting that the horizontal component of our force vector is the adjacent side of this angle 30 degrees in this right triangle. Okay, the horizontal component then is 20 cosine of 30 degrees times the basis vector I. And since the cosine of 30 degrees is root 3 over 2, we get 10 root 3i for the horizontal component. And then likewise for the vertical component, that'll be 20 sine of 30 degrees j. Sine of 30 degrees is a half, so we get 10j for the vertical component. All right, moving on then to question 5. Okay, it says a bug walks due east with a speed of 2 miles per hour on a sheet of paper that rests on a table. Suddenly, the sheet of paper starts moving southeast at 1.5 miles per hour. Let v sub p be the velocity of the bug relative to the paper. Let p be the velocity of the paper, and let v sub t be the velocity of the bug relative to the table. Okay, so you're given this diagram here with a little compass. Okay, so due east is to the right, and then north is up, right? So I've copied that diagram here. And so again, right, Vp, this is the velocity of the bug relative to the paper. So when the paper was not moving, we were told, right, that the bug was walking due east, so just to the right with a speed of 2 miles per hour. Okay, so that's this vector Vp. Now, when the paper starts to move, okay, the velocity of the paper, so imagine someone pulling the sheet of paper in the direction of this red vector. That's what P is standing for. Okay, and we're told that the sheet of paper starts moving in the direction southeast. Okay, so we're taking, right, a 45-degree turn here and heading in the southeast direction at a rate of 1.5 miles per hour. So the magnitude of this red vector P is 1.5. And then V sub t, okay, this is the velocity of the bug relative to the table. So if you have, say, another bug sitting on the table that's not on the sheet of paper, according to this bug, right, on the table, it would appear that the bug on the paper is moving in this direction here in green. Okay, now part A says write a vector equation relating Vp, P, and Vt. Well, from this diagram, we can see immediately that Vt is the resultant vector when we add Vp and P. So Vt is Vp plus P, and that does it for part A. For part B, find the magnitude of the motion of the bug relative to the table. So in other words, find the magnitude of this vector Vt, and then it says be sure to include units in your answer. Okay, so to do that, as we already noted, since the paper's moving in the direction southeast, right, this angle between the horizontal and Vp will be 45 degrees. And since the velocity of the bug relative to the paper, right, had a magnitude of 2 miles per hour, and due east is just to the right, Vp is 2i. So then note, I can find the components of the vector P using this right triangle, much like we did question 4. So its horizontal component would be 1.5, right? That was the magnitude of the red vector times the cosine of 45 degrees I. So that's going to give us 3 root 2 over 4i. And then for the j component, be a little careful here, right? Since in our coordinate system, due north is up and due south is down, right? And we're moving southeast. This j component will be counted as negative, right? So this would be negative 1.5 sine 45 degrees j. And so we get minus 3 root 2 over 4j for the vertical component of p. Okay, so now just noting that vt is vp plus p, and vp was 2i, and p, as we just found here, was 3 root 2 over 4i minus 3 root 2 over 4j. Combining components, right, we get 2 plus 3 root 2 over 4i minus 3 root 2 over 4j for the velocity of the bug relative to the table, and that's vt. Now we're asked to find the magnitude of this vector. So I then can go ahead and find the square root of the sum of the squares of these components. And so I get this expression, which I could simplify and be a little bit of a mess. So here, I'm going to go ahead and just use a calculator and do a bit of rounding. So this is about 3.239, and the units here, given that the units for the other vectors are in terms of miles per hour, this will have units of miles per hour as well. Okay, cool. So then what about part C? Fill in the blanks. The direction of motion relative to the table is blank degrees, and then it says blank of blank. Okay, so let me fill in what I'm talking about there. So looking at this right triangle here, where is this right triangle coming from? So if I go from this vertex, right, from the tail of VP and VT over to this corner right here, and then down, right, I'm going to call this angle theta. Now this side, which is the length of blue plus the horizontal component of P, right, that's going to be what? Well, 2 plus 3 root 2 over 4. That's the length there from here all the way over here. And then for the height here of this triangle, that's just the vertical component of the vector P. So that has length 3 root 2 over 4. And so now to find this angle theta, well, I could use the tangent. So the tan of theta is the ratio, right, of the opposite to the adjacent side. And then taking the inverse tangent and doing a little bit of rounding, this angle comes out to be about 19.114 degrees. Okay, so to fill in the blank here, we're going to say the direction of motion relative to the table, that's referencing VT here, is 19.114 degrees, that's this angle theta, south of, well, due east. Remember, right, the direction of the blue vector is due east, and so we're rotating 19.114 degrees south of due east to find the direction of this green vector VT. All right, well, that's going to do it for these two questions. I'll see you in the next video. Thanks.